Day 21, Part 5 notes. Let f of x and g of x be differentiable functions such that the following values are true. So now let's answer some questions here. So the first question asks, is the graph of h of x, it's really saying, is the graph of h of x increasing, decreasing, order of relative maximum or minimum when x equals 3? How do I know that? Well, I take the derivative. Derivative is positive, it's increasing. If it's negative, it's decreasing. So what I have to do is use the chain rule because h of x equals f of g of x, composite function. So it's kind of what we did earlier in the notes and on a previous problem. So let's do that right now. So remember, the chain rule is also known as the outside-inside rule. So we take the derivative of the outside, leave the inside the same, and then we take the derivative of the inside. But we're trying to find when x equals 3. So let's now replace c and x, substitute in 3. And because they don't give us anything in the table with h of x or h prime of x. So we're now going to do, um, again, everything with 3. So the first thing I'm going to look at is g of 3. Oh, what's g of 3? That's right here. I'm going to get a 4. So now that's going to tell me in a second to look at g of 4. Let's do g prime of 3. That's way over here, and I'm going to get 6. And now I need to keep going here, and let's find what f prime of 4 is. And hey, that's 8. So this right here has a value of 8. So the derivative of h at 3 is 8 times 6. That's 48. That's a positive number. So the graph of h of x is going to be increasing when x equals 3. Let's write that down. Okay, so as we said, it's increasing. All right, let's go to the next one. So if p of x equals g of 2x, what is the value of p prime of 1? So again, we're talking about derivative. I'm going to have to use the chain rule. So let's set this up, and once again, we're going to still have to use the data table. Again, outside-inside rule, so it's going to be take the derivative of the outside, leave the inside the same, but then take the derivative of what was on the inside. We're now going to, every place c and x, we're going to substitute in 1. G prime of 2 times 1, which that's going to be 2. Let me just write that out one more time. So g prime of 2, and I'm going to go to my data table, which g prime of 2. Hey, that's negative 1. So every place to see a g prime of 2, we know that's negative 1. And we had 2 out here, so they asked for, hey, what's the derivative of p at 1, or p prime of 1? And our answer is negative 2. Okay, one more question to answer. Okay, so the first thing we want to do is rewrite this with rational exponent, and they want to know what the value of q prime of 4 is. We're talking about a derivative, so we're going to have to use the chain rule here. So let's do that. So hopefully everyone can get to this step. Again, outside-inside rule, so outside, treat it like x to the 1/2. Bring the 1/2 down, that'll be 1/2 x to the negative 1/2. Inside stays the same, and then we multiply that by the derivative of the inside. Okay, I'm going to rewrite it, and then we're going to substitute in 4. Let me take 2 steps to rewrite this. Okay, so when we use the chain rule and then we simplify, we get to this step, and now we're going to find the value when x equals 4. So let's, every place c and x, substitute in 4. And when we look up at the table up above, f prime of 4 is 8, g prime of 4 is negative 2. Combine those, we get 6. And f of 4 is 1, g of 4 is 7. So we still have the 2 out in front of the radical. 2 square root of 8. So when we simplify, and you could really leave it to what I have here in the blue, 6 over 2 square root of 8, just because really all we need to know is that it's positive. And when I know the derivative is positive, then the graph of g of x is, should be q of x, is increasing when x equals 4. All right, that's part 5. And next class we'll work on homework 21. Good job.